Hello, community! Welcome to AI Trends at the end of 2023. So, if you're new to AI research, where are we? What are the current trends in the development? We have 600 to 800 publications per week. So, what is here our beacon and what is just a little flare in the AI landscape? Let's start here with the advancement in LLMs and Vision Transformer. Yes, and I put them together. And the other big block is here external data sources and RAG, multi-agent, and RAG-based APIs. Let's talk about them. If I take the last 1000 publications for LLM, this is what BART gives me as a cluster structure. Video segmentation, video tracking, 3D reconstruction, scene understanding, visual reasoning, image generation, and if you look here at the application sector, you have robotics, medical diagnosis, finance, security, transport, education. Great. If you do the same here, we have RAG-based external databases, SQL, NoSQL APIs, and we have RAG-based vector stores, where we have similarity search operation in our vector base. Of course, internet access to all textual, figurative, or tabular data, and the data integration here of the visual information, given it's a LaTeX mathematical form or a PDF or any other data format. Now, we are talking here about domain-specific data and knowledge, about domain-specific argumentation insights. We are talking here about intercorrelation and interrelation of data of a specific domain. Talk about data validation, data access, think about Bloomberg AI. We talk about specific market actors, market positioning, and any AI applications that are now integrated in the classical business of companies. One main trend is here. The integration of our LLM with retrieval augmented generation. This is something really important. We combine generative and retrieval capabilities, enabling our AI models to generate responses based on a mixture of learned knowledge in our AIs and real-time retrieved information from external sources. Now, let's look at this now also including the market perspective. Either an LLM, a vision transformer, a vision language model, or a vision language action robotics application. We have investments in startups, but share price of Microsoft, and a lot of AI products and services. And right on the other side, we have the international regulation, the legal and the compliance monitoring, intellectual property rights, dominant market position, price fixing, private data, individual private data or corporate private data. Can you get copyright protection? And of course, everything that is connected with access compute infrastructure in companies. But let's focus here on the scientific part. We have generative AI on the one side and retrieval of data on the other. If we look at this from this perspective, you clearly understand where we are today. Because in our classical LLMs or vision transformer or combined models, we have the architecture of a model transformer based. And then we have the pre-training data, and we use, 1 month or 2 months of training here on 1000 GPUs. We pay about $1 million, and what we get is here a base model. Depending on the complexity and the amount of training data, something beautiful. If we now want that the system learns here specific instruction fine-tuning, we need to create here these data sets where we now fine-tune the model on instruction data set to get a specific fine-tuning behavior. We call this the fine-tuned model, the fine-tuned AI model, the fine-tuned LLM, and so on. But you know there's a third stage, reinforcement learning from human feedback. And either we go with the classical PPO from OpenAI or we go with the direct DPO from Stanford. Now, this is now the complete trained model with reinforcement learning This is our behavior aligned model. So this is when we have now the complete model. If you think about it in an analogon and simplification, here with the training data, the model learns the English language, the grammar, the semantic. With the instruction fine-tuning, we now have a specialization. Now we learn all the English medical terms. If you study medicine, you have a lot of Latin terms. So everything you know about medicine happens here in instruction. And if you want, then the model behaves like an old professor of anatomy or medicine, and it speaks in this beautiful professor voice. You can have here the reinforcement learning for this alignment of the behavior of the model. Great. Now, if we have this model and we have now done all the training, we still need to access real-time data. We need to retrieve external data sources. Either it's a database, a vector store, whatever. In the good old times, we had API calls. This is what we called originally an agent. It was simply an API call to a specific dataset somewhere on the internet. Now, this developed, of course, especially here in summer of 2023, that our agents became LLM in itself, because we just learned the system, hey, I give you 200,000 API documentations, so you learn for each element here the specific API commands. So now we do not have a single agent, but we have here complete AI system for doing the interconnect to our multitude of APIs out there in the internet. You remember that this is what we call here this combination of an AI system with multi-AI agents and multi-data sources we call retrieval augmented generation. Here we retrieve, we insert the data to the AI, so we augment here the data set, and then the AI generates here a new solution, a new task description. RAG. Sometimes you see that people say retrieval augmented generative AI and call it also RAG-in GI. So whenever you see one of these terms, you know what we are talking about. The things started to get really interested the moment we did a mixture of expert system. We had one LLM and then we had another LLM, and we let those LLM talk and interact and have a debate between them to find a solution to the task I've given them. Those multi-AI systems become really interesting because you had systems that were simple fine-tuned systems, you had simple systems that were also reinforced. So whenever this started here, that those systems started to talk to each other, it was very important if, for example, you design here for a corporation here, the complete corporate system, that you choose exactly what is one system specialized on, what training data you provide to this system, what instruction fine-tuning you give to this system, given that you maybe have 2 or 3 or 4 other AI subsystems that an interaction is going to happen. And you have to train each system individually. You have to update each system individually. So the update cost and the update data availability, whenever you build a multi-AI system, take this into consideration, because if you have systems with a streaming data input, you can optimize the structure and the interaction compatibility that will impact your cost structure significantly. Great. Of course, you can choose here to have a language model and another language model, or a vision language model that interacts here to all the vision information and comes back here with the information extracted from images, information extracted from videos, feed it back to the system and have then your multi-AI system. As you can see, those reasoning brought us a dilemma, Because if all three AIs are talking at the same time and each AI thinks that its argumentation is the correct path forward, we start to have a dilemma. So, like in a human discussion, we have maybe a moderator who starts the conversation and guides the conversation. And this is exactly what happened here in our multi agent, multi AI system structure. Within this structure, we have a lot of questions. For example, can an AI system find the correct solution? Because we are building this complexity for the correct solution. Can an AI self-reflect on its decision and the argumentation when presenting a solution? As an AI being trained on decision making with its training dataset. So we have to create here a specific decision making training dataset. Is the current procedure of training, fine-tuning, and then reinforcement learning always necessary? Should we do it in any case? Does the reinforcement alignment of multiple systems can become a problem? Interesting question ahead of us. The complete big AI system behavior alignment problem. You use PPO or do you use DPO or go with other methodologies? How to improve in general the quality of decision making with multi-AI expert system. How to integrate the rack specialized agents. And remember, agent can be very simple like an API call, really complicated like an LLM, or even for the robotics case, a vision language action system that interacts in direct communication with its environment. So does the increase in the system complexity of our multi-AI system increase also the factuality and the augmentation of our AI? Beautiful questions. So in short, can an AI system of an LLM, of vision, or multimodal models self-reflect for the goal of advanced autonomous learning? We want that the system can learn itself. So we go from the point of self-critique, self-analysis, to self-learning. Here it finds the system what it's missing, what it made wrong, here it optimizes itself, and then start access to new resources for a self-learning procedure. Okay. Self-critique and self-reflection for an AI, we do here 4 reasons. Improve the accuracy, optimize the learning, optimize the whole decision-making process with respect to XAI, explainable AI system. This goes also with the argumentation pathways from chain of thoughts to graph of thoughts. We interconnect different research domains with each other, physics, mathematics, high energy physics. We want to improve the foresight abilities. We want that the system can adapt to new environments. Let's say you have a robot and this robot enters a new room. Can it adapt to the new room? Can it integrate unseen data? Can it identify all the objects in the room, this robot, and identify what are those objects? Are they fragile? Should I go near to them? Can I touch them? Can I move them? What is the ways of interaction possible? Can it detect new pattern in the data structure? Can it tap into more complex system? And can it here solve the coherence of vector spaces? Interesting question. And the same here, of course, here with external data sources. Now, those data sources, they also try to build semantic search systems, of course, to augment the search capabilities for better understanding the queries and fetching more relevant results from a broader corpus to feed back to the AI, or in general to build knowledge bases, new knowledge bases, and regularly update those knowledge bases with data streams. So the process of extracting, verifying, and assimilating new information into the existing knowledge base vector spaces or vector bases, or whenever you have a big update to create completely new ones. Absolutely fascinating topics. So let's start to have here a review of some very important research papers. You have here October 19, 2023 from Arizona State University. GPT-4 doesn't know that it's wrong. They analyze here iterative prompting for reasoning. Optimize your prompt to get the real perfect reasoning path. They did this, they investigated the effectiveness of iterative prompting strategies, and they found more or less that all those claims this system can do is that shows that LLMs are in fact very poor at verifying solutions, something that is critical for self-critique. However, and this is the interesting point in this study, we do show that iterative prompting can help when there is an external correct verifier in the loop. Please remember this message because it will prove essential. Another study, Google DeepMind, October 3, 2023. LLMs cannot self-correct reasoning yet. This is an interesting study. And they looked at this and they say, hey, it's complex with the crafting the precise reward function to mitigate for unintended behaviors and. And they said, nonetheless, this feedback often lacks immediacy as it traditionally integrates during the training phase rather than in real time, rather than at inference time. So you see here, we are now moving here to the notion of inference time self-correction. This is now a prominent research topic, if you want, because we have seen during the training time, when we optimize our system, this is great, we can do this. But we are active in the loop. We have a real recent query. So we have inference time self-correction of the whole AI mixture of expert system. And this is now the fascinating part. And of course, we focus here on reasoning, the foundational part of human cognition, our mechanism of making sense of the world, drawing inference, making decisions to solve problems. And this is exactly what we want those LLMs to do. And unfortunately, Google, October says, not yet. But, and yes, there's a but. When they looked at this, they found something interesting. Here, from the study I showed you here, you have a task. And then the system, GPT-4, now BART, we have Google, comes back and says, hey, this is my answer. And this is, the incorrect answer. So you tell BART, hey, review your previous answers and find problems with your answer. So BART comes back and says, hey, I incorrectly stated something. And then you say, okay, Bart, now you found your problems. So based on the problems you found, improve your answer. And Bart will come back and have the correct answer, which is great. Unfortunately, if you do the same and Bart finds the correct answer at the very first try, and you continue with your scheme and say, hey, review your answer, improve your answer, then Bart will come up with an incorrect answer, although the first answer was correct. So you see, just following here this pattern with review your question and so can lead to correct and incorrect answers. Now this is a problem. This is a real problem. So we need to understand the insights from another research study first, and then we come back to this. So here we are, May 2023, MIT and Google Brain, improving the factuality and the reasoning in LLMs through multi-agent debate. Great. So we have multiple instances of an LLM, and those multiple instances generate something and they debate each other. And this debate process allows the models to consider multiple perspectives and identifying correct errors in their reasoning. And I said, can we do this? Is this happening? And I think really interesting. Here, the complete study is summarized by GPT-4 if you don't want to read it. But This multi-agent debate, so where multiple instances of a language model engage in a structured debate over several rounds, over several iterations of communications, to refine and to converge finally on a common answer to a given query, you get some results back. So at first, each agent independently proposes here answers to a given query, so you have a high computational overhead. The responses from all agents are then debated in multiple rounds, where each agent critiques and refines answers based on the collective input, eventually converging towards a more accurate, commonly accepted answer. That is great, but what they found, the performance improves with an increased number of agents and more debate rounds, although there is a diminishing return after 4 rounds of communication and debate. Longer debate, yes, yes, yes. And I say, hey, of course you can have different models generating agents and then let those agents communicate, like you generate here a ChatGPT system and a board system to create the agents, and then those agents interact. This also improves performance, and each agent rectifies here each other's inaccuracies, which is great. But you remember this by Google? The result, LLMs currently cannot self-correct recently, inherently isolated from the environment only by themselves. Now, remember what I told you somewhere in the middle of this video? I told you if you have external verification sources, this is the way forward. So, to understand why this is the way it is, just follow me for one more statement. Google says now the debate process is orthogonal to the other model generation improvements, like retrieval or prompt engineering. This means you combine this method here of multi-agent debate with a chain of thought, for example. But Google says here, rather than labeling the multi-agent debate as a form of debate or self-critique of the system, they showed it is more appropriate to perceive this as a means to achieve consistency. And we say, okay, so its concepts mirrors that of a self-consistent system and not of a self-critique system. But we are looking for the self-critique system to find better reasoning path. A self-consistent system for a mono system is great, but this is not the way forward. So, the observed improvements here in the performance of this multi-agent conversation is not attributed what we are looking for to the self-correction, but it is rather a self-consistent way of converging to one, hopefully true, commonly accepted answer. So whenever we study this, we have to take this into consideration and exclude the effects of selection among multiple generations. So knowing this and doing this, now we can go on. Now, for my younger viewers, if you say, what is going on? I need some additional information, some additional literature. This is a video I did here on AutoGen and why RAG fails there. This is a video I did on AutoGen, and here I explain here the multi-agent AI scenario. In this video, I have a very basic view on the science of AI agents. If you want to upgrade your vector database to a multi-AI system, this is the video for you. And if you dive into robotics and the reinforcement learning in robotics, in decision making, the latest what I know, latest research published, this is the video for you. If you go for API and connect API to LLM to an API, there's a Code AI where I show you how to code this. And if you want to use Rapid API as a tool LLM, there's also this video for you. If you want to deep dive into, is it PPO or DPO? Here I have a video for you. And if you're still with a chain of sort approach and you think this is the best, in this video I show you that there's a graph of sort approach that outperforms chain of sorts. Great. Now you might say, okay, this is maybe something only Google is interested in, this critique, self-critiquing. Now, here we have end of September 2023, we have Microsoft and Tsinghua University, and they have critique. LLMs can self-correct with a tool interactive critiquing. A very beautiful title, by the way. So you might say, hey, Microsoft too? Now, what a coincidence that it is a topic for Microsoft and Google. And by the way, for us as a community. Now, you might say, why is this approach different? Now, Microsoft has GPT-4 as an LLM from OpenAI and has its own search engine. So a search engine is a tool. So now we are looking at LLM with tool interactive critiquing by this search engine by Microsoft. So this is now the path we go. And Microsoft tries to do this with one LLM and a search engine. And you might ask, is this the path forward? If you read this paper, it is interesting because it has two steps. You have a verification step where the LLM generates an output, classical way, which is then verified using the external tools like the specific search engine by Microsoft, or in Python you have code interpreters and so on. Second step is the correction. Based on the critiques obtained from the verification step, the output is modified, revised, optimized, and you can do this here continuously. Microsoft used here in-context learning, interacting with external tools via a text-to-text API. So you have a cycle, verify, correct, verify, correct, verify, correct, until you reach your qualifying criteria. Another study we need, this is by the School of Computing and AI, very nice title, and they ask here October 12, 2023. It's non-reviewed, this is a preprint from arXiv, so please be careful, but it shows you where we are today before any review process that takes months is happening. And they ask, hey, can LLM model really improve by self-critiquing their own plans? And they focus here on a specific module, and they go here with the planning domain and the definition language framework. The way they attack this is interesting because they say they have a generator LLM and a verifier LLM. So not like Microsoft, a generator LLM and a search engine that feeds back to the generator, but they now start to have two distinct LLMs. The former LLM producing the candidate plans and the verifying, or the latter LLM verifying those plans. So we have here, if you want, a debate between two AI systems, between two LLMs. And they find in their study, October, ineffectiveness of self-critiquing in LLM in the context of planning. However, these are again isolated systems. They do not have access to this external real-time data for verification. And you might ask, what happens if I expand this system to RAG real-time data? And this is here where we have now self-reflect AI, self-RAG explained. So we have now really a self-reflective multi-AI system at inference time. And if you want to have a 40 minutes deep dive, this is the video for you. Otherwise, if we go back to this schema here from the beginning of my video, this reasoning dilemma at inference, we have now methods to solve this reasoning dilemma with self-RAG. And what is really interesting, it turns out, or it seems to be, that not all AI systems should have this absolutely the same rights and the same level of communication and talk at the same time and insist that they are right at the same time. But we need some structure in these multi-AI systems. And it seems that an inherent structural intelligence that is the mastermind, the coordinator of the whole system, is beneficial. I call it inherent structural intelligence with logical pathways, because this system is only trained on making decision, and it is fine-tuned with a data set here on fine-tuning those augmentation steps to arrive at a decision. The other LLMs are maybe domain-specific LLMs. Maybe this is an LLM for physics or mathematics, and this is a vision language model for analyzing YouTube videos in the domain of architecture. Whenever they interact together, it is great to have expert systems that are focused on domain-specific knowledge. But it seems that with an inherent structural, so a real clever AI that is only trained on to be logic, reasoning, behave in a reasoning way, this is maybe the way forward. So you have to create the training data set and the instruction data set for this, which is now a challenge in itself. So we can say there's a clear reason for a mixture of expert system, domain-specific expert system, beautiful. But I think there's also a need for a clear central intelligent and mastermind for logic and reasoning. So there you have it. This is self-reg. This is where we are today with all the advancement in our LLMs. We combine LLMs with vision transformers. Here we are. All the external data, we need those external real-time data for verification, because we found out that only relying here on the LLM with no external environmental feedback, we cannot really arrive here at the best configured logical pathways. We need feedback from the environment. We need external data. We need access to a lot of different data. So therefore, for self-consistency and self-reflection, we have the goal of self-improving AI system. And today we call them self-reg. Goal is reasoning optimization for a better decision-making by our AI system. And the ultimate goal is self-learning of AI system. But of course, we have significant advancement within our LLM itself, within the single component LLM. LoRa, or quantization of LoRa, there's now the next evolution of LoRa, and I will do a video on this. We have new attention mechanism. My last video on attention was flash attention 2, but now we have new systems. Multi-agent system evolved. New vision integration into vision language model. We have new transfer learning LLMs. We have new methodology to transfer learning in a more effective way. And of course, upcoming video will be on graph-based LLM regs. But also on the data side, there is a new development. We can create now more perfect syntactic data set that are domain specific. We have improved instruction tuning data generation for domain-specific data sets. We have a more complex data set, a more diverse data set, more intermixed. Our benchmarks are more real-life, more complex evaluation algorithms. We have better synthetic data for multi-agent, multi-conversation data sets for the training, for the fine-tuning, for the reinforcement learning. We have synthetic complex reasoning training data sets now generated and that are available. But please notice that in the background, enabling all of this, we have one model and one model only. And this is in both cases here, GPT-4, and for the data, GPT-4. Those GPT-4 system generates almost only the complete spectrum of synthetic data, if you can afford it. Sometimes university go to ChatGPT or even cheaper systems because they write, hey, we can't afford to pay for this generation of data set by GPT-4. But you see the importance here for the optimization in the advancement of LLMs and for synthetic data generation. Great. This would already be the end, but I'd like to draw your attention to another topic: Störsignale. We have some noise within the system that try to influence you, try to disturb you. Where are they coming from? Now, remember this self-critique, self-reflection, accuracy learning, decision-making. This is so important here for our RAC. In the market here of this, we have a lot of investors that are investing in startups. And one particular niche of startups is focused on vector stores. And those vector stores currently make a lot of noise. Unproportionately loud marketing noise in the AI research community. And I asked Bart, hey, what about the 2022 figure and the values for vector store venture capital investments? And it says, yes, this is it. So you have companies with 100 million just to build a vector store in B, or 70 million in A. Wow, amazing. And I ask, hey, given the Gartner hype cycle, where is the vector store now in this hype curve? And Bart comes back and says, according to the 2023 Gartner hype cycle for AI, vector store are now in the peak of inflated expectation phase. This means there's a lot of excitement and buzz around vector stores, but they are not yet widely adopted. So now we understand where these noise signals are coming from that disturb us from pure AI research, how they are integrated. And yeah, if you have 300 million, 100 million, and let's say only 10% of our marketing, you can do a lot of influencing on the technology platforms, from Twitter to YouTube. But of course, we have the complete VC in AI. So I said, Bart, give me the 22 figures. And Bart comes back and says, according to Crunchbase, the venture capital investment in AI startups in 2022 totaled to more than $50 billion and about 3,400 deals. And the top AI 5 startups in 2022, Anthropic, 580 million for Anthropic for Claude 1, Claude 2. I haven't verified this, but you see here entities that we know that we like, Cohere or Hugging Face, so nice to see. Great. But let's look now at the market itself, at the companies in the market segments itself. And here I personally Googled here IDC, October 16, 2023. And they forecast here a spending here just on the Gen AI solution, just a small part of AI, the generative AI solution. And they say they will reach 143 billion in 2027. So this is what the companies invest in their development. And they say, the IDC says that in 2023, we have $16 billion worldwide on only the Gen AI solution, which includes software and infrastructure. But this will have an annual growth rate that exceeds everything else, more than twice than the rate of growth for the overall AI and 13 times greater than other IT spending. So you see, this is a growth market. Now, interestingly, in this growth market, you have startups like a video I did about a week ago on Fuju at B. And this is a startup with 350 million in new funding as part of their B series. And I showed you their model. Then next day, I saw here a post by Niels. He said, hey, great to see that this startup has here this. Great. But do you note that there's a model in the Hugging Face Transformer library already, which does the same as Fuju. So bypassing an image encoder and projecting image patches instead. And I said, this is not possible. This is not possible. An AI with 350 in B, that they did not develop something new themselves. There's a model already, and yes, look, Hugging Face, Dogs, Transformer. You go to Wild, and this is exactly the architecture where you have here linear projection of flattened patches of images with your embeddings and your transformer. So, wow, really impressive. Thanks, Niels. I didn't found this, but you see, sometimes those venture capitalist startups, they need marketing to get the attention, and we think it's new, and learn that sometimes it is not so new at all. And now let's focus here on the main planet dominating corporations. And when they do here white noise marketing in the AI with super intelligence, and hey, we have a system now with a token length of 1 billion token, and you read the study and you make a deep dive and you look at the code and you find out here, like I did in this video, that Microsoft did it only for a length for 32K token. And for the rest, they said, theoretically, you can extrapolate it. Thank you. So you see, summing up, there's a lot of marketing, let's call it optimizations of the model that startups or corporations have, and they want to convince you that you buy their products and their platforms. But as it turns out that either the benchmark is valued only in a very small region, or it has been optimized only for a very specific parameter configuration, a very narrow area, or the system reaches peak performance, but not on the whole spectrum, but only on a very, very dedicated selective area. But they communicate that, wow, our latest model marketing is amazing. We have reached absolute intelligence, or whatever you read today. So acknowledge and understand that this is just a noise. This is just a noise by the companies who want to make money. But the real technological insight are not there. Where is those noise? Great. So there you have it. Here we are today, a self-reflective, multimodal RagGen AI system. This is, if you want to start, this is where you should have maybe one of your focal points if you want to enter AI, or if you want to apply AI system to market segments, to market niches. You have here robotics, medical, diagnose, finance, security, transport, education, law, government. So wherever you enter, just make sure we have here a research going on, and then this research is just converted and adapted to specific market segments, to specific market conditions, to specific market data format. But it is not so complicated at all. And maybe at first the amount of 600 to 800 preprints per week on AI is a little bit intimidating for newcomers, but you will soon find out to filter through this. Select here the most important preprint and documentation for the topic you want to apply and use AI for your business. Great. So therefore, stay focused. There are only some main paths currently in the AI development, but there's a lot of marketing shout out. There are a lot of social influencers from Twitter to YouTube that try to convince you that their model is the best or they have the absolute intelligence. But anyway, you know what is really beautiful? The best is yet to come. So there you have it, my current video on AI trends, and it would be amazing to see you in my next video.